So a short video on precipitation reactions. Now, precipitation reactions, what we need to know about them is that it's when we have two solutions and those two solutions swap their partners, as you were, and they produce one insoluble product. So precipitation reactions actually produce insoluble salts. And the page that's very important for you when you're doing your precipitation reactions is page 8, and you look at your solubilities table here. So when I look at this reaction here, I have calcium chloride solution and potassium carbonate solution. Now what's going to happen is the calcium is now going to react with the carbonate to form calcium carbonate. And the potassium and the chloride are going to react to give potassium chloride. So that's what I mean by them swapping their partners. Now to identify which is which here, I need to look at my data booklet page. And if you look at calcium carbonate here, it's insoluble, whereas your potassium chloride is soluble. So this here would be a solid, and this would be a solution. So that'd be identifying the products that were made. If I was to write this as a chemical equation, so if you see that this is how to identify it as a chemical equation, so I would have my formula written as an aqueous, I would have my potassium carbonate written as an aqueous. On this side I would have CaCO3, and then on this side I would have potassium KCl aqueous. Now when I look at this here, I've got two chlorines here, two potassiums here, so I need to actually have a big 2 in there to make sure that's a balanced equation. There's videos on balanced equations and writing chemical equations if you're not sure on that. So when we look at this equation, again, if you were given this and asked what type of reaction's taking place here, you're looking for your state symbols. Two aqueous react together to form a solid and an aqueous. So again, we know that that's precipitation reaction. Another question you can be asked in terms of precipitation reactions is how you'd obtain a dry sample of the salt. So what you end up having here is when you put your two liquids together, what you end up having, and you have a test tube, you've got the liquid in it, but you've then got some solids settled at the bottom. So if you want to separate this salt here, this insoluble salt, you simply filtrate the solution. So it'd be filtration, and you would collect this here, the calcium carbonate, the solid, you'd collect that in the filter paper and then leave it to dry. Other contexts that precipitations can be asked in is in this particular context here when we're looking at the ionic equations, and we can be asked about spectator ions. So if we're asked about spectator ions, what we want to do is you're often asked to identify the spectator ions. So we would look for, again, we've got our two aqueous here and we've got a solid and an aqueous here. The quick way to do it is to look and see, right, well, I've started off with 4 aqueous ions over here, and I've finished with 2 still being aqueous and 2 turning into a solid. Now remember, our definition of spectator ions is that they exist exactly the same on either side. Therefore the 2 that started off, because they all started off aqueous, the only 2 that have stayed aqueous are these 2 here. So these must be my spectator ions because they've still remained in solution in aqueous. But I'll just double check one at a time. So I've got calcium 2 plus aqueous here, but my calcium 2 plus has changed into a solid here. I've got Cl minus aqueous here, and I've still got Cl minus aqueous here. So I was right, that is a spectator ion. And hopefully, if I'm right again here, my K plus aqueous is still K plus aqueous here. Again, spectator, spectator, exactly the same on either side of the arrow. And then my CO32 minus aqueous has changed. It's still CO32 minus aqueous, but it's now a solid because together these make an insoluble product. So if I had to ignore my spectator ions, what's actually happening in that precipitation reaction is that the calcium ions in solution are reacting with the carbonate ions in solution to form calcium carbonate in the solid form. So that would be me rewriting my precipitation equation with the omission of spectator ions.